Welcome back. We're in Chapter 27 QuizB question number 2. In Chapter 27, we're learning about inference for regression. And let's take a look at our prompt. A high school counselor was interested in finding out how well student grade point averages predict ACT scores. A sample of the senior class data was reviewed to obtain GPA and ACT scores. The data are shown in the table to the right. And clearly you see the table at the right. And just a reminder, how do you determine which is the X value and which is the Y values? It says GPA predicts ACT, so X predicts Y. Okay, so your GPA scores would be your X values and your ACT scores would be the Y values. Again, here's a graph of the scatter plot. Here's a graph of the residual plot. And here's a graph of the histogram for the residuals. This is the nearly normal condition that we need to met. We learned about that in video 1. Here's our computer printout, and we're going to be using that printout to answer question number 2. So question number 2, create and interpret a 95% confidence interval for the slope of the regression line. In video 1, we learned that when we are trying to infer information from a linear regression, we're going to use the slope. And we also learned that our null hypothesis is always there's no association between the X and Y variable. So how would we create a confidence interval? Well, let's take a look. And again, they gave us a helpful hint. They said a 95% confidence interval for the slope of the regression line. Okay, so here we go. So our 95% confidence interval for the slope of the regression line, which again we're using beta, capital B, and B1 is the slope of our sample, correct, would be given, just like every other 95% confidence interval, by the formula estimate plus or minus margin of error. Our estimate for slope is over here. Let's see. In our table, the coefficient of our X variable is our slope. So that is our estimate for slope. And we know in order to find margin of error, we need our critical statistic times the standard error for the slope. Well, where would I find the standard error for the slope? Also in the table, and clearly labeled standard error of the GPA coefficient, which is our slope. So here's our standard error, which we're going to plug into our formula. So here we go. Our estimate is the slope of our regression line, which is 7.397, again over here in our table, plus or minus our t statistic with 13 degrees of freedom. Just a reminder, when we're using linear regression model, our t is n minus 2, where n represents the number of data points. And we have 15 data points here, and n minus 2 would be 13. We're looking for a t statistic with 13 degrees of freedom for a 95% confidence interval. Well, we know in our calculator, if we go to second vars, we have our inverse t function. We're going to plug in 0.975 because we know a 95% confidence interval would have 2.5% on the right tail or 0.975 to the left tail. So we're going to do inverse t, 0.975, comma, 13, that's the number of degrees of freedom. And we get our t statistic of 2.16. Now, we need to multiply our t statistic times the standard error of our slope. And again, that standard error was given right here as 1.087. So we have our estimate plus or minus the product of our t statistic times the standard error for our slope. So we're going to do the calculations in our calculator. We're going to come up with the confidence interval for the slope. So just take a minute. And we should all come up with the confidence interval of 5.05 to 9.74. Well, what does that mean in context of this problem? Well, it means we are 95% confident that the ACT score increases an average of between 5.05 and 9.74 points for every additional GPA point. Okay, so let's review that again. We are 95% confident that the ACT score increases an average of between 5.05 and 9.74 points for every additional GPA point.